Alright, hello everybody. Welcome back. So, I'm going to be talking about section 1.4 today, otherwise known as algebraic expressions in the book. So, just a disclaimer here, this section only has examples. So, let's get started. Example 1. Negative 5y, or negative 5, parentheses, y plus 3, parentheses, minus 2 times y minus 8. Okay? So, you know that we're going to have to use the distributive property. And so, if it doesn't have a negative sign next to it, it basically means it's a plus. So, like, this, since it doesn't have a negative sign, it's a plus. But this has a plus sign next to it, so obviously it means a plus. And then this does not have, this is a negative 5. And then this is a negative 2. So now we're gonna solve it. So using the distributive property, we can do negative 5 times y, which brings us to negative 5y, minus 15, because 5 times 3 is 15, but negative times positive is equal to negative. Same thing with the negative 5 and y. And then, since it's negative times positive, you know it's going to be negative. And then it's a 2 times y, so then 2y. And then over here we have a negative times a negative. Right here negative, and then right here negative. So that's going to result into a positive number, which will give you a 16. So you're going to get positive 16. And then now all we just have to do is simplify the equation, and we get, so negative 5 minus 2y is equal to negative 7y, and then negative 15 plus 16 is equal to plus 1. Okay, so now we're going to move on to our next example. So our next example is a square, or a plus b whole square, where a equals 6 and b is equal to negative 2. For this equation, we are going to use PEMDAS. So first we're going to solve the parentheses, which is going to be a plus b. Then after that, we're going to do the exponent. Okay, so a is equal to 6 plus a negative 2, which is b, and then that's going to be squared. So we have 6 minus 2, because plus minus turns into a minus sign, and then we have squared, so then we have 4 squared, which is equal to 16. Okay, so now moving on to our next example. It looks a little bit more complicated, but it really isn't. We have to use PEMDAS for this one as well. So we have 2 parentheses a squared plus 1 minus 3 a squared plus 5 plus 4 a squared minus 1. Now if you know how to solve it, go ahead and pause the video and solve it yourself. Otherwise, just follow along. So we're going to do, instead of plugging in a first, we're going to solve it and then find a more simplified equation. So we're going to multiply. So 2a squared, we're going to use the distributive property, 2a squared plus 2 minus, and then 3a squared minus 15. Remember, positive times positive, or negative times positive is equal to negative. And then we have plus 4a squared minus 4. Positive times negative is equal to negative. Now we're going to simplify it, collect like terms. So the 2a squared minus 3a squared, that's equal to negative a squared. And then we have plus 4a squared, which is going to make it 3a squared. not a cube, a square. So then we have 2 minus 15 minus 4. So we know that 2 minus 15 is negative 13, and then negative 13 minus 4 is minus 17. So now that since we know that a is equal to 10, we can just plug 10 inside, and then we get 3 times 10 square minus 17, which is 3 times 100 minus 17, that's just 300 minus 17, which is equal to 283. So our next example is going to be a word problem. It's actually not a word problem, it's just turning words into algebra, or into an equation. So the cost of a 50-pound sack of fertilizer is $D. And then it's asking what is the cost per pound for the fertilizer. So we know that they're buying a 50-pound sack, and the cost is $D, and then it's asking per pound. So per basically means division. You always have to use division with per. So per pound it would be D over 50. Since you have 50 pounds and D. So the cost of a 50-pound sack is $D, and we know that a pound, it's asking for a pound of fertilizer. So we would just do the dollars divided by the amount of pounds we have, and then that would give us cost per pound. So this one is a conversion as well. So the length of a rope is y yards and f feet. Express this length in inches. So with 3 yards, wait, no, not 3 yards. So a yard is equal to 3 feet. Oh my god, I can't write a T. 3 feet, which is equal to 36 inches. And then a foot is equal to 12 inches. So since it's asking for inches, we got it into inches, and now all we just have to do is do 36y plus 12y. Or we probably shouldn't use y, just use x for inches. Okay, so that would be the solution. You could simplify it even further and bring it to 48x, really. But 36x plus 12x is also fine. So we have something over here. So the length of a rectangle is L centimeters. The width of the width is W centimeters. Express the perimeter of the rectangle in meters. So 1 centimeter is equal to 0.01 meters. So you really don't need to draw a figure, but if you really want to, you could. So I made a rectangle, and then just take, this is L, this is width, and then so L centimeters, and that would be, since it is equal to 0.01 meter, which is also equal to 1 over 100. Because I told you in, I think, the last video, that when you multiply with 100, or like any number with zeros at the end, the amount of zeros, so say we have 3.63, the amount of zeros is however many decimal places you move it forward. and the amount when you're dividing 363, you're dividing with any number that has zeros at the end. That's how many places the decimal moves back. So since there's 2 zeros, it would move back 2 places. Okay, so this is also equal to 1 over 100. So that would be L over 100. That looks like a 1. Let's just do that. So that's our supposed L. It may look like a Z, but it's an L. So then L over 100 is equal to W over 100. Oops. Or it's not equal to W over 100, but it's... And then you also have to do times 2. So now we can use the distributive property. And then we know that 2 over 100 is equal to 1 over 50. So then you get L, I'll just write uppercase L, over 50 plus W over 50, which is equal to L plus W over 50. And that is your answer for the last example. So my email will be in the description if you want to contact me for any one of your equations. Any equation that you need help with solving. If you're like ahead of the book, if you're ahead of the place that we're on and you still need help, feel free to email me. And yeah, I hope you have a good day.